Let's move on to refactorings. In the webinar preview in August, we previewed one refactoring. Well, we're shipping 4, 2 major ones and 2 minor ones. And these address common things you need to do in your code. Refactoring is all about code maintenance. As you develop, you need to change code, you need to move it around, keep it up to date, change things. That's what refactorings are there to help you do. And the key things we've added in version 12 help you rename a method or type anywhere it's used in your project group. This is what we previewed in the August webinar. But there are other things you might want to do, such as automatically add the right include for the code you've written. Or, taking some inspiration from a Delphi feature, you might want to write a method and have the declaration automatically added, or vice versa, write a method declaration and get the implementation automatically added. And that's what we have, so let's have a look at these live. First, let's look at rename refactoring. Renaming something is a very useful operation, so we'll use this test app, which is small but non-trivial real-world app which we publish on our GitHub, to demonstrate. You can rename anything, but here I'm going to rename the grid type because it's a key type used throughout the program. You can see when I open the dialog, it lists all the references it finds to grid, and there are checkboxes to control where it looks. Note that you can rename across an entire project group, not just one project, which is key. And also note that Visual Assist can find references in comments and strings. Refactoring is about code maintenance, and it's not good maintenance if your comments get out of date. So we can scroll through this and give a quick visual check what it will rename. It looks good. And also ensure that we check the checkbox next to the comment it found so it will rename there. And when we click Rename, it renames through the entire project and project group. Note when I go find that comment that it's renamed there too, which is unusual for any refactoring tool, but not for Visual Assist, because Visual Assist does things that are meant to be useful and go beyond what other tools provide. And of course, if I recompile, you can see the app still builds, a fundamental test and a very good one. Let's move on to the next refactoring, add include. In the slide earlier, we mentioned code completion and that it could complete for types that aren't even in the current unit yet. To demonstrate this, let's add a completely blank unit, and you can see that other than its own header, it has no other includes, and it does not know about key types. It does not know about C++ strings or vectors or maps, and does not know about even the types defined elsewhere in this program, because we haven't included them. So let's write some code, and we'll add 2 types. A system include like map, and one of our own apps types. We have code here that needs some include files added. Visual Assist works very tightly integrated to the symbol that your text cursor is in, which is worth remembering if you want to invoke functionality, that you need to put your cursor in the token that you want to do something with. For us, that's map. Let me put my text caret there, and then in the refactor main menu, you can see add include, and it tells us which header it's going to add, map. When I click that, it's added. Let me do the same now for grid. This time I'll use the editor context menu, and you can see again it tells us that for the grid type it's going to add a specific header. Now I have the 2 includes added at the top of my unit. Let's do this for a more complex case. Rather than a new blank unit, I'll go to some existing code. Now this unit is UE agnostic. It has no UE code at all. It doesn't know anything about drawing or buttons or anything, and we could include it into a VCL app or a command line app if we wanted. And I'll add a bit of code referring to a UE control, a T button. When I right-click and add include, you can see we'll add the include for fmx.stdcontrols.hpp. Now, there's a T button type in both FireMonkey and VCL. How does it know to use a FireMonkey header when we're adding an include in a file that has no FireMonkey present? The answer is that Visual Assist is aware of the framework you're using for your app and is able to know that you need the FireMonkey or VCL versions of a header. And this is the same for any other situation when it needs to resolve and find information about a type. And we've seen two things today. We've seen code completing types that the current code isn't even aware of, including with both types in our own project group, and the STL or any other headers that count as system headers, like the ones in Getit. And we've seen including the right include file for any type just by right-clicking it and selecting Add Include. Now let's move on to the two smaller code generation or refactoring operations, which also live in the Refactor main menu and the editor context menu's Refactor submenu. Let me add a method to the grid class. Now, normally I now need to go into the grid.cpp file and add the implementation, which is fine, but it's the kind of work that I should be able to automate. If I now right-click my new method, and remember that I have to click the name itself like everything else with Visual Assist, and select Rename Create Implementation, you can see Visual Assist goes ahead and creates a skeleton implementation for me. You can do the same in reverse and use Create Declaration if you create a method and want the declaration added. So those are the refactorings we've added to our initial Visual Assist integration. We have two large or major refactoring tools to rename any symbol and to add the include file for any type, and two smaller ones where you can automatically add a declaration or implementation.